Yeah, and we're building models of language learning, as I mentioned, that operate more like humans do. For example, our models only are trained on spoken language, right? There's absolutely no textual representations. We're using these architectures that are called generative adversarial networks, or GANs. They were used to be a popular, but are not as much in the engineering world. But from cognitive modeling perspective, so from modeling language perspective, they're very appealing because the network needs to learn to by imitation and imagination, and basically it needs to basically imitate what another network hears. So it works in a very interesting way where one network needs to trick another network into thinking that it's producing real data, and so that kind of mimics human speech production and perception. If you think of how we learn language, right? We listen to the language of our surroundings. We actually start listening to language way before we're even born. And we're trying to mimic that, right? The reason why we know that we listen to language before we're born is actually if during pregnancy, if you read the story to the baby over and over again, when the baby is born, they recognize that story. Or another reason why we know that language learning starts even before we're born is if, newborns of German-speaking parents cry slightly differently than newborns of French-speaking parents, because German has initial stress and French has final stress, right? Famously. So this basically we learn language. I mean, the complexity of sound that we probably hear and learn is higher than vision, right? So we learn language probably even before we learn how to see, and that's fascinating. And we learn by speaking, right? Another really fascinating aspect of language is that um, we have production apparatus preborn, built in our body, right? Which we don't have for vision. We see things, we perceive things, and we can imagine them for sure, but it's very difficult to access your imagination, right? You can imagine a big red apple right now, but I'm not seeing what you're imagining, right? Whereas for speech, you can always say new sentences, new words. You can come up with different words and so on. Be creative, and basically we're learning in this bimodal way where we're speaking and we're listening, and so we're basically building models that learn how to speak, but also exchange information. So where one model needs to encode information into sound, and then another network needs to decode information from sound. So and on the way, you really start observing. You can observe how the networks are learning in a similar way as human children are. Right, for example, when human English learners need to learn English, one nice example, right, is we have a short puff of air when we say a word like pit, right? If you hear p, there's a short H-like sound after the P. That's called aspiration, and that's a very interesting small rule of English where when your p is preceded by an s, that aspiration, that puff of air, that H-like sound gets lost, right? So pit with an H versus spit, right, without an H. And kids need to learn all those fine-grained rules, and you can basically see how kids do exact same developmental stages, so exact same mistakes, so to speak, as these networks as they're being trained and so on. And as I mentioned right at the beginning, you can not only kind of compare behavior of artificial neural networks and humans, you can also look inside our brain and look inside artificial neural networks to see similarities of representations. And for example, where the study that came out a couple of months ago, we were using this special brain imaging technique where you just put a bunch of electrodes on people's heads, and then you record with high sampling rate, which means that you're basically recording very early signal. So you're so when we hear things, the signal goes from our ear through our brain stem and then into brain cortex. Um, and so we're basically recording sounds when they're traveling through the brainstem, so very early on, and we're showing that their representations are similar to artificial neural network if you're catching that signal early on in the artificial neural network as well. So there's like there's a multitude of approaches that these new models allow in linguistics, and so that's really the exciting part.